What's up everybody, this is Engineer talking. Today we are going to be looking at an application of bitwise XOR operation. Today's question is lit code number 136 single number. So let's get into the question real quick. Given a non-empty array of integers, every element appears twice except for the one. Find the single one. So let's take a look at the example given. Example is gonna be like 2, 2, 1, and there like 2 appeared twice, but like 1 appeared only once, so we are gonna return 1. And in the second example, we see 1 like twice, and then we see 2 2s, right? But like we only see 4 once, so we are gonna return 4 in this case. Now, how we should do that? So something really simple, something really straightforward that might come up to your mind is that like we can probably make a use of hash map. For each element in the given list, we put that in the hash map, like he's gonna be the value that appeared in the given list, and the values is gonna be the number of times it appeared in the map, no, in the given list. So like take second example, say hash map approach. Keys value, and value is count. Then second example, like after iterating all the elements, second example will yield 4 equals 1, and key of 1 is 2, value of key 2 is 2. So, and then after iterating all the given elements, we can iterate once again over the hash map and then see if there's like any keys out there of which the value is set to 1, and then we return that. Now this is gonna work. What's the problem with it? There's no problem at all. I guarantee this is gonna work, but it's not that efficient. That's the thing. We can do better than that, and that's the whole purpose of this question, and that's what this problem is wanting to tell you basically. So what's the problem? Like, why is it not very efficient, right? So let's talk about complexity a little bit. What's the time complexity and space complexity of this approach? It's gonna be O(n), like time-wise, because we are iterating over elements twice. That doesn't matter, but we are basically iterating over the given elements. So that's O(n) time. And the space-wise complexity is gonna be like O(n), because we are gonna be storing like n over 2 elements in the hash map as well. So space. And we want to do better than this, right? And how can we do better? We can either decrease the time complexity or space complexity, but like how would you decrease time complexity better than O(n) when we like absolutely have to iterate over the given input? So like O(n) time is pretty optimal to me, but like space complexity wise we can do better. So that's where the bitwise XOR approach kicks in. Can do better with. All right, so now that we know we are gonna be using bitwise XOR, like for those of you who are not really familiar with bitwise operations, let's talk about it, talk through it once, like what bitwise XOR does and what kind of properties it has. So let's get to that. Like, so what is XOR? XOR means given 2 bits, return 0 when 2 bits are the same, otherwise return 1. So the truth table is gonna be when input is 0 0, then return value will be 0, and 0 1, return value is gonna be 1, 1 0 1 1 1 1. Oh no, 0 in this case. So this is what XOR is going to be like outputting basically, and what kind of properties XOR has. That's the key point of this question. So we are going to be doing XOR on like A and B. A XOR B equals B XOR A. The order doesn't matter, and also another property it has, XOR C, A XOR B XOR C. And then you can apply XOR to the first 2 elements or you can apply XOR to the last two elements first. That doesn't matter. All I'm trying to say is it doesn't matter which order you are applying XOR, like as long as you apply XOR like across all the elements. So given that, and then another property we should be talking here also is that A XOR A is gonna be 0. This is very, very important property in this question. So like whatever number it is, like if you XOR with the same value, then the output is gonna be 0, because every bit is gonna have the same value as the element that we are going to apply XOR, and then like every bit is going to outputting 0. So the entire result of the XOR operation is going to be 0. And that's pretty much it. So the key insight from that, like say, take example 2 again, then we have 4, 1, 2, 1, 2. So what's going to happen? We apply XOR across all the elements in here. Then 1 XOR 1 is going to be cancelled out and it's going to be 0. 2 XOR 2 is as well going to be cancelled out, and then the value is going to be 0. And then we have left with 4 XOR 0, which is going to be 4. So I should have talked about it as well. A XOR 0 meaning A, because, well, what if the value was 0, 0, 0, 0 here? So in the case of like 4, the bitwise value of 0 is going to be 0, 0, but the bitwise value of 4 is going to be 1, 0, 0. And then we do XOR operation there. Then first bit is going to be 0, and then other two is going to be 0, 0. So meaning like whatever the value is, if we apply XOR with 0, then the same like value is gonna be like the output of that operation. So yeah, and as I was saying, so all the elements in the list is gonna be appearing twice, meaning if we apply XOR, they will be cancelled out like with each other, and only element that appears once in the list will outlive the XOR operation, and that's gonna be the final return value that we wanna output. So that's pretty much simple, right? And what's the gain of this approach? We gotta talk about it. Like we are gonna be iterating through the given list once, so no change in time complexity, but spacing complexity is gonna be of 1, because we are keeping only the XOR values, not like we are keeping entire values in the list. Like, so yeah, that's the thing. So here in the hash map approach, the intermediate data structure we are keeping is hash map, which is of n space complexity. But in this approach, XOR approach, the intermediate data structure we are keeping is the XOR value, which is of like integer type maybe, which takes 8 bytes or 4 bytes, right? 4 bytes, like constant. Whatever number of elements the given elements has, the intermediate like result is gonna be of integer type. That's it. No other thing required. No other like ON data structure required. So hence of 1 space complexity we can do. Let's get to the code. Like, so for those of you who are not really familiar with the bitwise operations and its properties, I just walk through like all of that, but like code is gonna be pretty simple, pretty straightforward. We are gonna be iterating through this given list, and we are gonna keep like XOR value here, and then XOR is represented as this caret kind of space 6 character, and apply the given element over and over as we iterate through the list, and then finally return that. Pretty simple. Like we talked all this much to just write like 5 lines of code, actually like 3-4 lines, right? And then we can submit this, and this is gonna be the answer, because it should work. It is supposed to work. So yeah, Okay, let's wrap it up. So in this question, we talked about like some important like properties of XOR operation. Meaning like if we apply XOR to like same number like to myself, then result is gonna be 0. And if we apply XOR with like a number and 0, then the output is gonna be the number that was appeared first. So like using that, we wanted to figure out which element appeared once while others appeared twice. Then we apply XOR across the elements, and then whatever the result is gonna be that element we wanna figure out. So yeah, hope this video was helpful to you, and if it was, give it a like and subscribe. I will see you in the next video. Bye.